Okay, two more problems. First of which deals with a pyramid. Now, I've drawn the pyramid and I drew different parts of the pyramid. I took triangle EFG and drew that separate outside of the pyramid, so I took that triangle out from the inside. And I drew the floor of the pyramid up here so that we can analyze the pyramid by looking at those simple geometric figures. So, looking at the given information, if the distance from A to B is equal to 6, we'll look at the floor. The floor is a square. We have a square base pyramid, so each of the sides is equal to 6. But then that means the distance from the center of the square over to the middle of one side, that segment has to be equal to 3. That 3 then translates over to this segment down here for the triangle that came from inside the pyramid. That's equal to 3. The given information says the distance from E to F is equal to 4. So therefore we can use the Pythagorean theorem to solve for x, which would be the slant height of the pyramid. But we have 3 squared plus 4 squared equals x squared. So we have 9 plus 16, which is 25. If that equals x squared, x equals the square root of 25, which is 5. So slant height is equal to 5. Now the formula for lateral area of a pyramid is 1/2 times the perimeter of the base times the slant height, L, which is what we just found to be equal to 5. The perimeter of the base is the distance around this square, 6 plus 6 plus 6 plus 6. So that's equal to 24. And 1/2 times the perimeter of the base times the slant height. 2 goes into 24 12 times. 12 times 5 is equal to 60. Lateral area of this pyramid is equal to 60. For a cone, the formula is basically the same as for a pyramid. I like to state that the lateral area is equal to 1/2 times the circumference times slant height instead of perimeter times slant height, and then total area equals that answer, lateral area, plus the one base that we have. We don't have a ceiling, if you want to think of it that way. So I'm just going to move those formulas over to the side. And we'll move those right there. So looking at the triangle inside the cone, we have a right triangle, and we have the distance from A to B, which is the hypotenuse of that right triangle, is 13. The length of one leg is equal to 12. So we can solve for x, which is the radius of the base, by saying x squared plus 12 squared equals 13 squared. We solve for x by saying x squared plus 144 equals 169. We subtract 144 from each side of the equation. We have x squared equals 25, so x, which is the radius, is equal to 5. So let's look at the formula for lateral area. We'll just shrink that. And lateral area deals with finding the circumference. So we'll write down circumference equals 2 times pi times the radius, which we just found to be equal to 5. So we get the circumference is equal to 10 pi. So we'll bring that over to the side. Now we have lateral area equals 1/2 times the circumference of the base, which we just found to be equal to 10 pi, times the slant height, which was given as equaling 13. We have 2 goes into 10 5 times. 5 times 13 is equal to 65. So we have a lateral area of 65 pi. So we'll bring that over to the side. Now we'll state, based on this formula, that the total area equals the lateral area, which we just found to be equal to 65 pi, and add to it the area of the base. The area of the base is the area of a circle where the radius is equal to 5. So the area of the base, represented by capital letter B, is pi times the radius squared, so that's 25 pi. So we plug that value in here. Added with the 65 pi, we get an answer of 90 pi for the total area. I hope all this helps. Good luck on the exam.